Look at some more information about vectors. Um, Previously, remember we talked about a vector is a directed line segment, and it has made up of components. And so the components are a horizontal component and a vertical component. And we use this little notation to show it. For instance, if I had a vector started at 1, 1 and went to 3, 5, that vector right there. If this was point A and this is point B. Sorry about that. It goes from A to B. That's the vector AB then. And in component form, what that is that's the head minus tail, right? Or we just count 1, 2, that's the vertical component. And then the horizontal or vertical component is counting from here up to the next to the head, 1, 2, 3, 4. So then component form, that vector is the vector 2, 4. Okay? What we're interested in is finding the magnitude, the length of this vector. And so just in general, if I have a vector v, then in component form is AB. So what that is that's a vector of some kind. Here's vector v. And this length is A, and this length is B. And what we have is a right triangle. And so in trying to find what this is, the magnitude of it, it's called magnitude of vector v. And all that is just the length of the vector. Okay? To find that then, it's just using the Pythagorean theorem. Now the magnitude is given, another notation that's used is the absolute value. Those are the same thing. There's no significance to that. It's just it'll always come out to be a positive number. The magnitude of that then is the square root of a squared plus b squared. So if we want to back up here to this example, and I wanted to know what's the magnitude of vector AB, it would be the square root, well, this is A and this is B, so it'd be the square root of 2 squared plus 4 squared, which is the square root of 20. And you could use a calculator if you want a decimal to make it from there. Okay? That's how you find the magnitude of a vector. There's our formula for it right there. Okay, so now we're going to look at some examples. Let's say I want to find the component form and magnitude of the following. Let's say I gave you that we had points P, I'll write them up here. P was the point 3, 5. Q is the point negative 2, 2. R is the point 4, negative 3. And S is the point negative 1, 7. Okay? Let's say I have those points, and I want to find the following. I want to find the component form and magnitude of PQ. I want to find the component form and magnitude of QS. And third, I want to find the magnitude, component form and magnitude of SP. All that's really important in finding a component is to realize the head minus tail. So I'm going to do Q minus P, as far as the X is and as far as the Y. So PQ is going to equal Q minus P, negative 2 minus 3, and 2 minus 5. which if we work that out, we get -5, -3. The magnitude of that then is going to be the square root of this is A, this is B, so -5 squared plus -3 squared, and if you work that out, -5 squared is 25 plus 9, which is 34. QS. S is the head, so we're going to go S minus Q. So we're going to go -1 minus -2 and 7 minus 2. So I'm going to get that that is equal to minus a minus is a plus, so it's 1, 5. The magnitude of QS then is the square root of 1 squared plus 5 squared, which is the square root of 26. Last one then, we're going to look at SP in component form. So P is the head minus the tail. So we're going to go P minus S. So we're going to go 3 minus -1 and 5 minus 7. There's our component form. Simplifying, minus a minus is a plus, so it's 4, -2. Okay, so then the magnitude of SP is going to be given by the square root of 4 squared plus -2 squared, simplifying square root of 20. And there's finding the magnitude of those vectors. Now, we can do vector operations as well. Let's say that we had, so vector operations, adding and subtracting vectors and multiplying by a number. So let's say that I gave you U was the vector in component form, it was 2, 4. V is the vector -2, 3. And W is the vector 3, -5. Let's say we want to find the following. 1, we want to find what U plus V is. 2, we want to find out what 3 times W is. And the third one, we want to find 2U, looks too much like a W, minus 3W. So we can do all these operations. Basically, it's just doing this. So if I want to do U plus V, all I do is add the horizontal components and add the vertical components. So that's just U plus V is going to equal 2 plus -2, 4 plus 3. If we were subtracting, we would minus in here instead. So that comes out to 0, 7. And there's what the sum of those two vectors is. Okay? 3 times W. This number right here is what's called a scalar. Kind of a weird name. It's just a number that's not a vector, but sometimes we multiply 3 times the length of W. That's what we might be talking about. And so all we're doing is making 3W 3 times longer. And so all you do is just multiply. So this is going to equal 3 times 3 -5, which is going to equal 9, negative 15. That's pretty straightforward. Problem like this then, all we're going to do is take u and multiply it by 2. So if I multiply u times 2, 2 times 2 is 4, 2 times 4 is 8, so this is 4, 8, minus 3 times w. 3 times 3 is 9, 3 times negative 5 is negative 15. We subtract, so 4 minus 9 is negative 5, 8 minus negative 15, minus a minus is plus, 8 plus 15 is 23. And there is what that difference is going to be. So we can do operations with vectors as well. And that's what's going to be on your assignment for today.